So, good afternoon. We're trying something a little different here with an exciting panel. I have the privilege of having an esteemed set of guests, and I'm going to introduce the remote ones and then the ones in the room, and the ones in the room can come up as I introduce them. So we have a six-member panel. The six-member panel will be discussing why doesn't the internet migrate entirely to IPv6. Three remote panelists, three panelists who are here, so we'll be going through in a pretty strict order to make sure we can keep things organized. The first panelist, I don't know if he needs any introduction, a gentleman named Vinton Cerf of Google. Vint, are you out there? Do we have Vint available remotely? Yes, very good. We also have joining us Jeff Houston of APNIC, also a man who needs very little introduction, and then Brett McIntosh from McNet Solutions, our three remote panelists. Here in the room, if I could have Byron Holland. Byron, you here? Come on up. And Lee Howard. Byron is with Sierra. Lee Howard, IPv4 Global, and Gerald Much from Akamai. Come on up, Gerald.
In the order he called them.
Byron, Lee, and Gerald. Very nice. This will keep my mind straight. Okay, so I actually gave them a set of questions that they can be prepared for. I'm going to go through them in order, and I'm going to let each one respond. And then we'll open it up to your questions. But let's do mine first. So each panelist, I want to address the topic of the question of why does the internet completely migrating to IPv6, what does that mean to you? And do you think it will ever happen? That's the first opening question. So really, I ask with Vint, what does the internet completely moving to IPv6 mean to you? And do you think it'll ever happen, Vint?
The answer to the second part is yes, I think it'll happen. I think that IPv4 will still be around, but IPv6 only capability is going to be important. I'm going to take advantage of having grabbed the microphone to suggest that I would start with an apologia, and that will offset what Jeff Houston has to say, which is to explain why we are so stupid as to think that IPv6 will ever happen. So, 1996. We adopt the standard, and I thought, and a lot of other people thought, we would implement it immediately because why not? It wasn't a very big network at that point still. The trouble is that the dot boom was underway thanks to our friends at Netscape Communications going public. And the result was people who had plenty of v4 address space didn't pay any attention to v6 because they didn't need to, and they were too busy catering to the World Wide Web and the dot boom. However, with IoT and mobile and 5G and everything else, I think that the number of devices that we expect on the net is enough to justify moving to a larger address space. So I think we should just stop tinkering with it, which is still happening, and get busy and implement it. We need to shake out the security bugs. We need to verify interoperability. We need to assure cloud implementation. We should reintroduce the interop process where people demonstrate their ability to interwork. We should have hackathons. Procurement process should include incentives, because if it doesn't, it inhibit or impede adoption of IPv6. And finally, I think we should all be demonstrating at least that we can run with IPv6 only, so we nail down the whack-a-mole problems of reliance on IPv4. So I think that we should do it. I think we could do it. And Jeff and others will explain to us why we haven't done it.
And with that, I'll thank you, Vint. I'll turn it to Jeff. Jeff, what does completely moving to IPv6 mean to you, and do you think it'll happen?
Yes, good afternoon all, and it's good to be here, even virtually, and I wish I was there in person. Look, John, I'm going to wind it back even further than Vint and look at the late 1980s and the evolution of networking at the time. There was this big issue about how do we identify endpoints? And the whole idea was we were going to use these permanent tokens that both the network and the host could use to identify itself. These were addresses. And the whole internet was based on static addressing. When we, in 1989, got told by Frank Solinsky the plan was falling apart and we were going to run out of addresses, we started two things going at once. One was the short-term fix,
Right.
and the other one was the long-term solution. Interestingly, the short-term fix was address sharing. It was the idea that we would suppress for clients the fact that they needed a permanent address. We'd just loan them an address. Now, this is interesting because the evolution of computing wasn't that everyone runs a mainframe. We don't have a billion mainframes out there in the world. We have billions of clients. And clients, as we've found, don't need addresses. So fascinatingly, we've built a server-client network that uses names as its currency of connectivity. And addressing is actually a 1980s concept. Now, we still need addresses. We still need those ephemeral session tokens to distinguish one conversation from the other on the net. And so far, V4 is holding out in many places, but even with sharing, even with all of that, we're seeing the end of the barrel. It's running dry. So what's going to happen is that more and more, as we deploy V6, particularly in the big retail networks, and you see it in all the big mobile networks, as we move to V6 in the servers, the networks move to V6 by default, thank you, happy eyeballs, and the pressure on the NAT pools decreases.
Right.
And so I can run bigger and bigger retail networks with smaller and smaller pools of V4 addresses because the NATs don't matter anymore. What does that mean? Well, eventually V4 is going to just slowly whimper and die, but it won't matter. We won't see it because we're name-based networking in all but name.
Right.
We're now doing tricks with names that we never thought possible. Tens of thousands of web hosts sit on one IP address. So all of a sudden, addresses don't matter.
Okay.
And by the time we stop looking, V6 will have disappeared. And that's the definition of complete migration to me. Thank you.
Okay. Thank you, Jeff. I'll turn it to Bren. Bren, what do you think? What does the end of IPv4 or complete migrating to IPv6 mean to you, and do you think it'll ever happen?
Awesome. Good afternoon, all. It's a pleasure to be here to meet such great colleagues. So I'll give you my perspective. And initially, I focused a lot on what's happening in the Caribbean. And as you know, the Caribbean is it's pretty small when you compare it to the rest of the world. And we usually follow the trends of the bigger countries. I spent a lot of time looking at research from Vincent, from Jeff, the APNIC results, Cisco, 6Lab results on IPv6 adoption and readiness statistics. Now, to me, those are just components of, moving to full migration. Would it ever happen? Absolutely. When? I just can't say, because to be honest, at this stage, I didn't even think we would have gotten as far as we have reached with IPv6 adoption and migration. So while, we're wondering if it would ever happen, there is great progress being made. But just to give a little insight of why I think it will happen. As to date, we're seeing content delivery networks like Akamai, your Google, your Facebook, who has fully migrated to IPv6. The challenge that we see is that smaller businesses and enterprises and smaller ISPs are still lagging because, I can get IPv4 addresses still, even though we have completely run out of IPv4 address space I can get from IPv4 brokers. We're even hearing talks about maybe the Class E address space, maybe being freed up to provide more IPv4 addresses, right? So the question is, when will it happen? And to be honest, we can't say, but I think that is going to happen, but it's going to take a holistic effort. And I think Vincent and Jeff really put in perspective of what can happen and what should happen. That said, though, it'll be great later on to share some more perspective on that entire full migration. But to sum it up for me, full migration is when we have every network running IPv6 natively. And that's my take on it for now, John.
Excellent to hear. Really good. I'll turn to Byron now. Sarah, what does completely moving to IPv6 mean to you, and do you think we'll ever get there?
So coming from the names side of the names and numbering house, I probably have a slightly different perspective, or at least maybe just a different set of metaphors. But when I hear completely, I actually think of what does that word actually mean? And completely is, is it from telco, routers and switches through ISPs, DNS operators like myself, web hosting shops, on down to the very edge in home networks and those routers that have been in closets for a decade or more. Or as Lee said to me this morning, smart TVs. Right. Now, is that full stack completely going to be migrated to IPv6? I mean, I think the short answer is not anytime soon. But that doesn't mean it still shouldn't be the goal, and particularly as Internet of Things really takes root in a meaningful way. Of course, it needs to still be the goal. But I look at it probably a little bit more like, take something, not a politically hot topic at all, but something like the electrification of the automotive fleet, right? I mean, ironically, given the timeline we just heard about, late 80s, early 90s, GM had a pretty good, at least city-based electric car. 30 years later, we're really just starting to see that market take shape in a really meaningful way. And it's probably going to be decades more before the fleet is electrified, which if you're a car guy or a car woman and you've driven the latest and greatest combustion versus electric is just better, even if you're a car guy, on many, many ways, in many, many ways. And we can argue qualitatively, is IPv4 better than IPv6 or vice versa, but let's say, at least from a scale perspective, IPv6 is better. We're headed that way. I think we just need to be ready for a much longer transition than perhaps this community would ideally like.
Good insights, very nice. I'm now Lee Howard with IPv4 Global. That's one of the people with the providing IPv4 addresses to those who want to keep it going. Lee, what's your thoughts on moving completely to IPv6, and will it ever happen?
It's a really interesting panel for me to be on. I think it's a good idea. Thanks. I think you've given me a great point to start from in what's the definition of completely migrate to IPv6. It seems to me that I don't care if there are pockets of IPv4 in some dark corner of a data center somewhere or in somebody's home someplace. That's not what matters to us on the internet, right? For the internet to migrate to IPv6 means that you don't need IPv4 in order to connect usefully to this superset of networks that connect to other networks in order to interoperate. And so that's what I would be looking for. When will we stop using IPv4? Well, when will we stop using DECnet or SNA? When do we stop using, the buggy whips? There are still buggy whips being manufactured because there's still people writing buggies. Okay, that's fine, but we don't need to manufacture our roads to be exclusively capable of handling buggies anymore. Right. So when we need to, what will it look like when we migrate there? We'll have pockets of connectivity or maybe even pockets of disconnectivity to the rest of the internet. And what I'm mostly concerned about is making sure that the things that need to be able to connect to each other can use a common protocol. Probably the long-term best protocol would be IPv6. And so when will it happen? It's increasingly happening, but I don't know. Don't know.
Hey, actually, I don't know is one of the world's best answers.
It is turning out to be a longer tail of migration than I had hoped 10 years ago.
Okay, I'll now turn it to Gerald. Gerald, what does completely moving to v6 mean to you, and when?
So I'll actually start by answering the when. I think we're probably about 25 years away from that.
A date.
So, set your calendars, come back to me in 25 years, and let's have that conversation. But I think we're probably out there on a horizon like that. But I think, the completeness, I think a lot of the other members of the panel got us there, is completeness is when an end user who's using a device in their home, on the mobile network or something, can't tell. For me, that's the real test, is when a consumer using the service. The technology people, just like the car analogy and everything else, we're going to care about all of the inner workings of it. But if the end user can't tell the difference of what address family, what IP protocol is being used on the other device, that's when we have truly, completely migrated, I think. And that's really when it's going to be there. But I think when you talk about product life cycles, You're probably about
25
25 years.
Okay, very good to hear. We have our next question I posed to the panelists was, what are the hurdles? What are the hurdles of getting there? I mean, 25 years is a long time. I don't know. I heard another, I don't know. It could be decades. Why is it so long? What are the big hurdles? What do we do about them? I'll start with Vint again, with our remote panelists, and move to Jeff and Brent afterwards. So Vint, what's the big hurdle?
Well, one of the big hurdles seems to be getting the ISPs to offer IPv6, and for a long time that wasn't happening. It's beginning to happen. I used to make regular calls to Verizon and Fios saying, when can I get my IPv6 address? And I actually got it just about, I don't know, 3 weeks or 4 weeks ago. They came out, installed new routers, and voila, I now have both v4 and v6 capable devices around the house. So I think the ISP impedance has been part of it. My understanding is that most equipment, edge equipment, whether it's laptops or pads or routers or what have you, all have v4 and v6 capability available, even if it hasn't been turned on. And so my argument is that it's mostly ISP impedance that is why, but I'd be very interested to hear different perspectives from the other panelists.
Okay, very good. Jeff, Mr. Houston, what do you think of the big hurdles? Audio, we're missing you.
Yeah, sorry. The first hurdle is thinking the internet's one network, where it's actually thousands of component networks. And what we actually see are a number of different markets with different perspectives. Markets that are expanding and booming are actually more advanced down the v6 path. So the mobile markets, the consumer markets, they're actually embracing v6 very quickly. I might look at India. They're now sort of 70% of the country is now v6 enabled because they decided to launch a $2 handset. And that massive expansion said they had no choice. Right. So not only did Reliance Jio do it, but the other 4 big providers did it. And what we see in many economies, Vietnam, Korea, America, is that the big markets have already moved because they're under growth pressure. So who's not moving? Well, interestingly, when you look at v6 numbers, weekdays are lower than weekends. Lower.
Yep.
Enterprise markets are not moving because there's no need. They're not growing. So they're quite happy to use old technology because they understand security issues, they've got their tools developed, they've got their staff. You know, for them it's a comfortable non-decision to wait. And because the perspective is v6 doesn't do it better, it just mitigates future risk, those enterprise markets feel under no pressure. So that diversity is a big factor here. Some markets will move quickly, the big ones, the smaller ones won't. The second issue is the price of v4. For almost a decade since exhaustion, the transfer markets were pegging the price for v4 address really quite low. They didn't move. They went from about $12 an address US up to $20 over that 10-year period, right, which really reflected a view in the industry that said, what problem? There is no scarcity. We're not reflecting scarcity in price. Last year, the price doubled in a year. Right. There is an increasing view that this resource is under competitive strain in the marketplace. And quite frankly, that strain is the other huge factor that is driving transition. Because as I think Tony Hayne pointed out many years ago, and probably Lee Howard as well, Lee, one of the biggest incentives is if we get to $1,000 an address, it's not going to stay there for long because we can't afford it. It's going to collapse at that point. And so watch that price. That's a big signal. Thank you.
Excellent, Jeff. So we need more growth to drive v6, and we need higher prices. That's good to know.
I'll see what I can do.
What's the hurdles?
Yeah, so John and team, to be honest, there are tons of hurdles. And how do we solve them? Again, that can be a long list. Initially, when I was looking at the questions, I was sort of focusing on, what's happening on the Caribbean side. But I'm so happy to hear that some of the, challenges, mentioned by Vint and Jeff, it's pretty much similar to what's happening in the Caribbean, right? That said, though, a critical aspect of getting IPv6 migration on stream is what value is it bringing? And I say that because I had many discussions when we started the IPv6 forum in Grenada as to what can we do to help push this process of IPv6 on. And we had the topic. The topic was maybe customers need to put more pressure on ISPs because ISPs were the ones that were not making the moves at all.
Right.
And that said, the responses were customers would never, ever put any sort of pressure on ISPs to migrate to IPv6 because as far as they're concerned, they have the end-to-end services that is working no problem. So one of the challenges we see, and similar to what Lint was saying, in the Caribbean, we see ISPs are making moves, not fast enough, but that's a challenge. And I did some research a couple of years ago for, in a couple of ISPs that I work for. And the question was, okay, guys, it's time we need to start focusing on our IPv6 migration.
Right.
And the executive team, the first question they would ask is, can you just do a cost benefit analysis and let us know? And then we can make a move, maybe not move. So the issue of cost, what it would take to actually do that, that has a lot of bearing on that transition process. We see ISPs, and again, I'm focusing on ISPs because that is where I see one of the major hurdles is, right? They're happy to continue doing carrier grade NAT, IPv6 assessments, replacing hardware, all these are challenges for them. So these are some of the key areas, right? A second one that I would want to focus on for just a few more seconds is security. We're moving to cloud, so a lot of cloud services. While cloud security is now a big thing, it's still not fully understood. Moving workloads into the cloud connected by IPv6 might be another challenge. In a review with technical engineers on IPv6 migration, security is always one of the top priorities from my experience. Most times they can tell me 1,000 reasons why we should not move to IPv6 as opposed to maybe 2 reasons why we should. So you have the education, the value proposition, security concerns, and the general competitive nature of businesses. Is this going to make me make more money? How is this going to help my business? So it's a lot of hurdles, John and team, but we can get over these hurdles. As to how and when, again, that's up for discussion.
Got it.
Thanks.
Brett points out there's a lot of things we need to work on. Yes, Byron, what are the hurdles? Is the DNS a hurdle?
I think DNS is going to be the savior, actually.
Oh.
Look, there's Jeff nodding. Thanks.
Yep.
Back me up on that one. I think in terms of the hurdles, though, we just heard one of the key ones, which is ISPs. If you think of, from their perspective, and I'm not an ISP, but if you've got to roll a truck with a service tech, put in a new device, depending on traffic, it's a couple of hours. The cost of that per home, and you're going to have to call that customer and say, somewhere between noon and 6 p.m., a tech's going to show up and enter your home. Mm-hmm. Other than going to the dentist, that's kind of the next lowest priority on anybody's mind is having an ISP tech show up. So you've got that, but downstream of that, and some of these are my customers, there is no appetite to do work, to do engineering work, to get new gear where there's no revenue associated with it. And for me to try to push that, right, to maybe have a flag day or stop a service or something, there is just no appetite for that. And these are key channels through which V6 must flow. So that to me is one of the big stumbling blocks and hurdles, because there's no customer demand, there's no revenue flow. The flip side of that in V4, this kind of incredible organic market has come up over the last, pick your timeline, but decade or so. Obviously policies have been put in place over time, but this was capitalism doing what capitalism does. It sprang organically from this space, created its own market. Now there's some rules and policies. But until, economics 101, that supply and demand and the price, and Jeff talked about it a little bit, that continues to satisfy the market right now. Mm-hmm. And until that price escalates to the point that people aren't willing to pay, then there's not a lot of pressure to migrate, interestingly, to this giant free pool over here.
Right.
But there's this wall and hurdle, and the price isn't high enough yet to get us over that hurdle. And until that starts to change, I think, the laws of supply and demand will be in effect.
Got it. So Lee, apparently the problem is you just need to charge more. Can you talk about the hurdles? Apparently your low prices are hurdles.
Apparently the fact that prices have only doubled is insufficient. And of course, I don't set prices. Like that's the people who have addresses that they aren't using decide how much they're willing to accept, and people who need more addresses than they have decide how much they're willing to pay, and that's how it becomes a market. And I don't know. Of course, I think it was Jeff said everybody should do a cost-benefit analysis, and I think I did that when I was working for an ISP, and said I can deploy NAT, or I can buy addresses, or I can deploy IPv6, and what's the right combination? And I shared my thinking with Nanog, and I came back 10 years later and shared it with Nanog again, and I've been pretty public about that. But of course, everybody has their own calculus. To my mind, there's three legs to the stool. There's the network operators, and I divide those up. I think that I disagree with everybody else. I think ISPs are doing fairly well. The growth in IPv6 on ISPs is linear, and it's been linear for several years now. It's not the swooping up into the right curve that we were once seeing, but it's continuing to grow apace, and that will continue as networks deploy IPv6 and as CPE is swapped out. But there's also the enterprise operators. This is back to, and the enterprise operators who don't have growing networks, or any operator, as Brent was saying, any operator that doesn't have a growing network doesn't need more IPv4 addresses, so it doesn't matter how much IPv4 addresses cost. It's not going to be an incentive for them to avoid that cost until they come to a point where they say, maybe I want to sell my ISP because it's worth, the addresses are worth more than the revenue. I don't think we're quite there yet for most cases. So that's a hurdle that I'm worried about, is what do we do with the people who have enough addresses? Enough. And there's no motivation for them right now other than maybe lower latency. I worry about content. I'm not seeing quite the rate of growth in content deployments as I have been seeing in eyeball networks, whether it's mobile or ISPs. But mostly I worry about, and Byron said this, mostly what I'm worried about is the consumer electronics. It's the devices that nobody is buying their next smart TV based on whether or not it supports IPv6. Why would they?
Right.
And so the real hurdle to me is the complexity of the externalities of, I need everybody to adopt IPv6 so that I can avoid this cost, or so that I can make this revenue. But I can't influence those third parties over there to enable IPv6. And that's the hurdle that I've been trying to figure out a way how to get around, and how to make it more of an internet community of ecosystem where we can influence each other. And I've had some ideas, but I don't think that we're ready to try and apply pressure to those companies who aren't going to see a direct revenue or cost avoidance benefit from deploying v6 or enabling IPv6.
Got it. Interesting approach. The thought that as we're sitting here, we're building a bigger hurdle in devices that don't support IPv6 because they're being bought and they don't need to today.
And so that's, if we go back to the question of when,
Right.
and well, it's when the last current smart TV is off,
Right.
is out of the last household. And so that's maybe,
where my time
is it
frame
25 years? Maybe, yeah.
Yeah, that's.
Go ahead, Gerald. 25 years. It might be longer if we have a lot of these TVs.
Well,
What do you think the hurdles are?
I mean, we only have an hour for the panel. So I think that's the challenge, is that, there is an insurmountable list of hurdles that we need to clear. So one of the biggest ones I see out there is what I'll call the building code issue, right? We have this new framework. It's been defined for over 20 years now, codified in RFCs. This is how you do it. But we have all of these new networks, and they're the ones who are standing up, and they're using these new standards because there's a shortage of the address space. All of these existing networks out there, all the existing back-end systems, OSS, BSS, all of those types of systems, they need to also enable IPv6 on their side. They need to update their databases. They need to move to native IPv6 data types on the backside. moving all of these things, these hurdles, each one is a small one, but these are the things that prevent websites from turning on v6 on the front end. When I talk to website operators, they say, we need anti-fraud, anti-abuse, good geolocation for our end user data to go and identify who's accessing our website and such. I was in Europe about a month ago for IETF. I couldn't go to my local county government website because I was physically in Europe and they have the IP addresses geo-blocked. And so are they going to go and say, okay, now I need to import a new data feed for v4 versus v6? You know, like they don't have the sophistication. They have to rebuild all of this. So part of the reason for my 25-year prediction is it's not just about the technology and the systems that we've deployed today, but it's also about the people. The people who are buying the equipment, the standards that everything is built upon, and some of us who are used to memorizing and being like, oh, I know the IP address of the first DNS server I ever typed in because I typed it in 4,000 times when you had to manually do stuff before DHCP was really a thing. You know, I've got that embedded in my brain. I don't think I will ever forget that IP address. But on v6, you can't do that. And so you have to change that entire mindset around it. You have to change people and how they think and how those software systems work and how do we go about reducing the friction of deploying the technology. Because it's really about that friction and interacting with it. You know, they mentioned, Lee mentioned the smart TV, right? It's, you know, nobody's going to buy their newest smart TV based on that. They're going to buy it based on a bunch of fixed priorities, which is going to be the technical specs of the display, probably maybe whether or not it supports the Wi-Fi standards you're using in your house, maybe an Ethernet port, and that's probably about it, unless you're, you know, really worried about how a bunch of them do like pixel, you know, data privacy stuff. Like, after that, you're not going to go and do that. And you just want that consumer electronic device to work. And if it doesn't work, then, you know, the person's going to return it to the store.
Got it. So given the issues, I mean, the addresses you've memorized and everything we've heard of the last answers to these questions, let's go contrarian, okay? Lee raised an interesting point. If IP addresses get so valuable, someone's going to turn around and say, maybe I don't need mine, I'll sell my business. Maybe I'll switch to using that and free up addresses. Do we really have to do v6? I asked each of the panelists the question, should moving to completely IPv6 even be a goal? Do we care? Why don't we just reutilize much better? Think of all the addresses that haven't actually been liberated by companies using them today because they're not at a high enough price. We might be able to keep this running for decades and decades. Is v6 really a necessary goal? I asked this to the panelists. Vint, what's your answer?
Yeah, I think it's still a necessary goal. Part of it, if we could get there, it would be simplifying the world because having to run both stacks all the time just seems like an additional burden, to say nothing of opportunity for security problems. I actually have a question. You can fit it in maybe later.
Sure.
There's a scenario where eventually you can't get IPv4 at a price you could afford, so you choose to use IPv6. Other people who are still running v4 have customers trying to reach the IPv6 people.
Right.
How do they get there if they don't have IPv6 available? That argument was used to try to convince ISPs they should at least get IPv6 in addition to v4 to allow their customers to get to the v6 only people.
It's a good question there that we'll need to pick up in Q&A.
Okay.
No. So Jeff, what do you think? Should v6 even be a goal? I mean, there's a lot of addresses if we slice them really finely.
Well, let's continue that thought. Let's press a little hard on that button. So we're using NAT. So we've taken 32 bits and we've added 16.
Right.
Wow, that's 48 bits of usable address space. But that's not all. We're time sharing those extended 48-bit addresses. So the true capacity of IPv4 is equivalent to a 1980s address space of around 52 to 53 bits in size.
Okay.
Interesting. Because in our current deployment plans for v6, a lot of ISPs are giving end customers 48 bits.
Right.
Now, the issue is if we pack v4 as tight as it will go, and then go, all right, now we've really run out. v6, come on down, your day is now. And v6 goes, oh, hang on, we're full too. This doesn't work. because we've been so extravagant in V4. We relived the early class ABC days of V4 and V6. We've been so extravagant in V6, and we're handing out addresses like there's no tomorrow. We've actually replicated the same density factors in V4, oddly enough. We've made V4 more efficient, we've wasted V6. It has about the same address space. We're going to hit the same wall twice at once.
Right.
This is a problem. So let me continue the other thought. The other thought says, we don't need no addresses the way we were using them. Happy Eyeballs is not an addressing issue, it's the first DNS response. We are making the DNS jump through extraordinary hoops. The whole reason why I've spent the last 5 years deep inside the DNS is I think the DNS is the internet's future. We are doing name-based networking, we just don't talk about it. That's where we are.
Got it.
Names are much more important than addresses, John. So does it matter if we do V6 or not? Well, as far as I can see, no. It's just a cost we push down the stack to the commodity folk, because the real money is in apps and names. The real money is not in shoveling bits around and addresses. So, you know, I don't think we're going to care anymore in a few years. It just
We're not going to care. Doesn't matter. Okay. Brett, Jeff says that we need to make it a goal because otherwise there's a dead end that we'll hit sooner or later and there's no out at that point. What do you think? Does V6 have to be a goal?
Yeah, I absolutely think it's going to be a goal. And from the perspective of being a dual stack end user and an IPv6 geek, you know, I pretty much test every application or every website that I go on and just compare at times the performance. You know, to actually gauge the performance, you really have to be deep in this. And, you know, I love the end-to-end performance of IPv6. Would the average end user know about that? Maybe not. Right? But that said, I'm just thinking of the, you know, now with the focus on IoTs, I mean, what else is going to make the difference but IPv6? As a matter of fact, maybe about 3 months ago, a neighbor of mine told me, he said, I'm deploying some security cameras for a client, and I noticed that they're getting a private IP address, and I have a challenge because I now need to go and enable port forwarding. Is there a solution for this? This guy is a brilliant, you know, IoT type, you know, installer, but he has no idea what IPv6 can do.
Right.
I said, yeah, there's a solution. It's called IPv6. And that said, having that true end-to-end connectivity, I think that is how the internet is meant to operate. Of course, as Jeff mentioned, DNS being, you know, the core of that sort of connectivity. So yeah, this is absolutely should be a goal. And I just want to add, and I was going to speak initially about the education process, because I can speak of ISPs in the Caribbean now. I didn't get a sign off in time to actually mention that ISP, but they are moving to full native IPv6.
Oh.
I've been checking on Cisco 6 Labs, and I've seen small islands in the Caribbean, you know, their IPv6 deployment index has moved from 1% to as much as 14%. That said, though, some form of NAT64 is still happening, but the intent is there, and that's what's important. So while the actual process is slow, we understand that it seems to be a goal for ISPs, and so in the case of Caribbean ISPs. And if that's the goal, then absolutely we're heading in the right direction. But personally, I think it absolutely should be where we should head.
Got it. Very good to hear. So apparently we need to get back architectural purity. They doubled down on. Vince said the same thing. Byron, what do you think? Does V6 need to be a goal?
I think it does, absolutely, in spite of the fact that we're in a seemingly a very, very long transition period. I mean, given the number of devices that are coming on, it seems to me that we must have it as a goal. On the other hand, as we slice and dice V4 more effectively, more efficiently, as that market has germinated, you know, we can all do the easy math. I think the high watermark is $60. 4 billion addresses, that's a $250 billion market, kind of one way to look at it. Are people going to get creative and effective on slicing and dicing and timing? Probably. $250 billion at stake, probably. And what will that do over time it probably just continues to push out that timeline.
Yep.
That said, IPv6, I believe, certainly has to be a goal, though, if anybody reads Jeff's research, which I'm sure most people here do, there's, concerns about performance and effectiveness of IPv6 right now, failing over to v4 still at probably unacceptable rates. Yeah. There's still some work to be done, so I actually don't see that transition time extending as a bad thing.
Okay. So Vint says we have to get there. Jeff says we have to get there. You say the efficient market may be pushing that out.
Yeah, you have literally countervailing forces at play here. Now that this market has germinated in the way that it has, its interests, the market's interests, arguably, are a countervailing force to the more rapid, in quotes, adoption of v6.
Lee, do you think the market, do we have to actually get to v6? And if we do, is an efficient market getting in the way of that?
Well, that's an interesting question. So when you ask the question, should IPv6 be a goal, my response is, for whom? Because for some people, when I was working at an ISP, it was absolutely a goal for us because we knew that we were going to have to, because we knew we were going to run out of IPv4 addresses. We kept turning up new services and adding new customers, and we have to do something. And so we did the math. In that case, an efficient market was absolutely a countervailing force that drove us towards IPv6.
Got it.
But there are non-market participants, and this back to we've got the enterprises and the consumer electronics folks who don't feel the pinch of either market prices or of running out of addresses. So there's less incentive for them. Although there are still, I wrote a guest blog for ARIN a couple of years ago about IPv6 has lower latency than IPv4. That's an interesting potential argument that some people might care about that's not market related. And actually, I've talked to some companies that have said, wow, that's really exciting. We were not concerned about buying addresses, but if I can improve our performance by 15%, that's fantastic. It turns out, this is somewhat related to the question Vince started to ask, I think that part of the reason that v6 performs better is that Android doesn't require IPv6 in software on their handsets, on their devices. Yep. So they have a shim in there that translates from IPv4 to IPv6 in the handset on a v6-enabled mobile network, and then it gets carried out over the mobile network over v6, and maybe gets translated back to v4. I think that shim, that software, is adding a little bit of latency. And Apple requires all of its apps to at least certify that they work with native IPv6, and therefore they don't add that latency. Maybe Jeff can set up a test to do this. I haven't been able to set up a lab to confirm this theory, so I'm just sharing the theory in case somebody else can run a quick test while we're here and let us know how that performs.
Got it. Very good. Well, we're hearing, IPv6 gives, the end-to-end architecture gives better intelligence for geolocation and lower latency. And I mean, this is sounding pretty good. It's almost like an electric car versus a combustion car. Gerald, is the experience that much better on v6 and we're just not marketing it? Do we have to get to v6?
We absolutely have to get to v6. Yep. It is really the future of where we're going. I think Jeff hit on it earlier, is that we use the DNS system to go and translate all of these things. And I think 25, 30 years ago, everybody was thinking, okay, you have identifiers, you have end-to-end, you have all of this stuff. Almost all communication happens from a client device to a server in a few selected cloud providers or service providers of some sort. And the way we initially got through some of this initial IP address sharing stuff is in the HTTP spec, we added the host header. Well, what's the host header? That's that DNS name that Jeff was talking about before. We did this back, in what, the late 90s, where we added the host header as the identifier for talking to. And so when you go and you look at this and you say, okay, how do I do all of this stuff? You end up with this entire ecosystem that is heavily driven on IP addresses. I don't go into my firewall and configure www.akamai.com as the thing. I configure an IP address. Once we can figure out, okay, how do we get the technical ability? How do we get audit and compliance and a lot of these things in place? I think that's going to help. The other thing is, in a lot of the smaller markets, for a big carrier like a Verizon or AT&T or Time Warner Cable or Comcast, here in North America, they manage the device at your house for you. They specify the firmware, they test it, all of that, up to that CPE device, up to your house. For a lot of the smaller markets, it is still not default to have IPv6 on. This is a huge barrier. So if you're a small to medium-sized ISP, you're actually probably using a MikroTik device or Ubiquiti equipment or one of these other carriers. And when you're going and using that, I own on the side a little, I call it my hobby ISP that I run. I've got V6 enabled, and I get V6 requests from 3 customers or so, or 4. I think it's maybe 4, and 3 of them I personally turned it on their routers because it wasn't default. And so you've got folks like, Amazon's got their Arrow brand, and it's interesting because, I look at somebody like an Amazon, just like, anyone else. It's like, okay, they're getting IP addresses on the V4 side, and the consumer electronics they're producing have V6 turned off by default on the other side. And you have to go and take these companies and bring them together, not only internally. We have the same challenges that, inside of my own company. Don't mean to pick on Amazon, but we have these same challenges in every single company of how you get these systems, how they work together, how they cross-work. Because, ultimately, it may end up being, it doesn't matter that, the end user's on V4 and the origin is on V6 because you're going to have something else in the middle, be it some CloudFront or Akamai or Fastly or Cloudflare or somebody else who's doing that translation for you, and they're doing that as a service either for the website or somebody else, and that's what we've largely gone to is people don't want to run the servers. Like that's why AWS and DigitalOcean and all those places have been wildly successful. Is people don't want to run the servers. They don't want to manage that infrastructure.
Right. We absolutely have to get there, and we need to use services to do it. We can't all rely on Gerald, the IPv6 angel, configuring our DHCP.
It's lead. Yeah, no, but you have to have, somebody is filling that gap already in the marketplace, and it's making those things default. And people at Akamai have tried very hard to go and say, okay, we want V6 to be on by default for all of the new websites. But going and touching every existing customer config, changing it, that's the hard part. And that's where we need that progression of time.
It's interesting. We've had all the panelists pretty much say we have to do this. This is a goal we all have to share. Now, ARIN, of course, our philosophy is whatever. You want V4, you want V4. You want V6, have V6. It's interesting because we're kind of involved in addresses, and our philosophy is, historically, has been do what you want to do, okay? So I guess the question is, and I did pose this to the panelists, so none of them should be particularly shocked. As a regional internet registry, if we have to get to IPv6, what should ARIN be doing? Vin, what's your thoughts on that?
Well, if you'll forgive me for one anecdote, some of you must be well aware by now that Google ran out of IPv4 address space in its cloud and it had to switch over to IPv6.
Yep.
Rather interesting. The second thing is that in the cloud world, this is not like the early days of a single CPU time sharing system where you landed on that machine, that the IP address mapped directly to that machine, and then you got access to whatever processes there were. In the cloud, you land on a thing that figures out which machine you're supposed to land on in the cloud. And that's often a load sharing system, and it's an opportunity to terminate protocol and open up something else to get to the interior. And so that makes the end-to-end notion somewhat less clear because the end may be at the edge of the cloud's implementation. Anyway, your question is what should ARIN be doing? And I think ARIN is doing the right thing, which is enabling parties who need address space of any kind to somehow get access to it. So if you facilitate access to V4 through brokers and you facilitate access to V6 by allocations, both of those things seem to be the right thing to do.
Okay, very good to hear. Jeff, what should ARIN be doing? If we have to get there, what should we be doing?
First, and most importantly these days, the RIRs are not what they used to be.
Wow.
They used to be the guardians of conservation. They used to be the folk who were trying to extend the life of V4, which in 1990 was predicted to be 4 years, for as long as they possibly could. So they were the rationers. They were the gateway to which you had to humbly beseech and make your case in order for everyone to have access. And that was almost their primary role. But there was a second role that I think is now the primary role, it's taken over, which is the registry. The one place where that unique association of the address holder to the address is maintained as a public record. So whether I get my addresses from a direct allocation from an ARIN or from the marketplace, or I picked them up somewhere out on the street, it shouldn't matter if I obtained them legitimately and can prove that to the satisfaction of the registry. I'm the registrant, my record should be there.
Got it.
Collectively, those 5 RIRs should be able to accurately say at all time where addresses are, who's got them, all the time. If you do that, that's 95% of the job done. Just be a good registry and no barriers. If you've got the address and it's legitimate, allow me to express that in your registry, John, and the other RIRs, and I am the world's happiest little address holder.
Got it. Keep track of where they are, and it really doesn't matter if it's V4 or V6. That's 90% of the job. Okay? Brent, what do you think? What should a regional registry do? What should ARIN do?
To be honest, this was my favorite question because I didn't have to give it much thought. To be honest, John and team, I think ARIN as an internet registry is doing their fair share. And there's 2 points to that, right? You are supporting and engaging your stakeholders, with your IPv6 deployment, stories and publications and, supporting, publicizing, what other companies have been doing in IPv6 migration. It's a big deal. Reason being, we have learned a lot from it. And again, I always mention the Caribbean experience because we tend to normally adopt the technology that is now becoming popular around the world because we're small. Secondly, I think you have a really, really great supporting team in ARIN. This has been, maybe for the year, maybe my 5th or 6th supporting a client to apply for address space. And it's becoming easier every time. Now I know your team by name, and they will say, okay, no problem. You only have to pay for I know this is specified in the NUPA, but you just pay for the IPv6 allocation and the /24 you're gonna get, don't worry about it, right? But what can you do, John? And I think ARIN should just continue doing what they're doing. It's as simple as that to me, because I think we already have a great platform.
Okay. Byron, what should as an RIR, what should ARIN do? If we have to get the V6, what should we do?
Well, as a fellow registry operator in a different space, first and foremost, I agree with one of the comments made, like job number 1, run a highly effective, efficient, and bulletproof registry. So, which includes who has what, where, and when, and the ability to transfer, register, transfer, et cetera. So, to me, that's job number 1.
Right.
I think that there's also an opportunity potentially for a little more activist role in terms of education and awareness. I mean, right now that may feel like shouting into the wind, but nevertheless, as a center of expertise and knowledge, the ability to share that, to educate with the different types of actors in the space, and also recognize that given this market that has developed around IPv4, where ARIN may have started as purely a technical operator in registry, now there's an element of rules of the road for this market, and kind of owning that and doing the best possible job of making sure that you have good, fair, transparent end policy and policy making process around that, because that's here to stay for a while. And I think, it's a huge market.
Got it. Okay. Lee, what do you think? As an RIR, what should ARIN be doing? If we have to get the V6, what should we do?
I don't think I've ever been shy about telling you what I think ARIN should do. And so an example of what ARIN has been doing well is when RS got up to give his presentation on how to use Git to pull the history of the NRPM, I said, Git, really? Oh, you're going to show me GitHub, and I'm going to say there's no quad A, and I'm going to be, my hair's going to be on fire. And then he went, no, Bitbucket. And I went, of course, Mark chose Bitbucket because it has a quad A. And I did a dig, and sure enough, ARIN is requiring IPv6 for its services and has been doing so for a long time and is doing it well. And I keep spot checking and going, whoop, once again, there you go, good job. So I appreciate that. There are a couple of other things that I have seen. Afrinic has done a couple of IPv6 deploy-a-thons. And I was able to go to one of those and support the team, and it was a really interesting to say, and they had some requirements. You have to bring a laptop capable of running an emulator that can actually emulate a network of a decent size. And we sat down with the team with the different networks operators who were there. We helped them build out their network in a model, and then say, let's come up with your address plan. And then let's talk about how you're going, what are the commands that you need to issue onto each device? And we started working through them on the technical details on how to roll it out on a backbone and then how to begin rolling it out towards the edge. Really interesting, really useful. And all of those initial ones, I forget what the number is, but all of them have at least done some level of IPv6 deployment on their network. So that's a really good one.
Very helpful.
I was talking to Edward earlier this week also about the Nanog hackathons. There's still a surprising amount of open source software that does not support IPv6. I think Chris gave me the example of Hadoop. Kind of silly that it doesn't there. That's another case where maybe ARIN could either sponsor or provide some test beds or force developers.
Got it. Very helpful. Okay, Gerald, last one on this question. If we have to get the V6, what should ARIN be doing?
I don't think much more. I don't think much, honestly. ARIN should be really focused on its core function, which is maintaining the registry of the numbers that have been subdelegated to it from IANA, allocating out of those pools, and then I think additionally, if anything, it's ensuring that when people are coming for services, coming for numbers, go and say, we have a lot of this whole IPv6 thing for you. It's really great, and here's our supplier list, and our website all works on it, and all of that. I think it's more of making people understand that this is actually a real legitimate strategy for executing. And I think what Vint said earlier about Google Cloud, and I think there's Mythic Beasts in the UK who offer like IPv6 only services, and that's the first thing they do. I think also OVH, started doing that as well, where you have to pay extra for V4 and stuff. But going and pointing people at these services where it say, hey, here you go, it works fine on your cell phone. If it doesn't work at your home ISP, maybe you need to upgrade your equipment there, or you need to have a conversation with them. But if you go and you say, hey, it works on my mobile handset, I don't know what's wrong with your system, you need to go talk to your IT guy.
Right, that's an issue.
I think, it's a bit of an issue, but I think that's the type of message need to be, sending.
Got it. Very helpful. It's quite a diversity of views here. So we're going to start opening it up to questions from the microphones, remote and in the room. People can start lining up at the mics or submitting remote questions. I'm going to pick up something that Vint raised, and I'm going to pose it as a question to the panel. And Vint, I may not get it right, but it triggered something in my mind. We may have some people who decide V6 isn't for them. Some operators who just say, I'm going to keep going with V4, I'm going to keep it running. And when they do, the cost of keeping the V4 only crowd and the V6 only crowd connected, it's borne by the V6 community right now. Is that really fair? Is it really, if we go 20 years and we have pockets of V4 that are only V4, when is it that they didn't run the translator, not V6? Any of the panelists want to talk about that?
Yeah.
Lee, you want to talk about
it? That's exactly precisely to the externalities that I was talking about, is the people who are paying the transition costs are the people who most need the growing network. I will say that part of the reason that I worked for an IPv4 address broker is that I tried working for a company that was providing translators between IPv4 and IPv6, and it turns out I can push 200 gig through a 1U pizza box, but turns out there's not that much demand for it. It's just too easy to do on your own or with commodity hardware. So I wasn't able to make the sales.
Got it. So you think that it's going to be the way it is, and that's just unfortunate?
I haven't figured out a way around it. I will say that Google's open access NAT64 does seem to be an interesting move in that direction. The DNS64 platform they've developed, released.
Okay, we're going to go to the mics. Do I have a remote? Anyone on the remote mics? Yes, in the back. Go ahead.
Question from Steve Wallace from Internet 2. Question for John. Can you describe your vision for the future of IPv4?
Folks, I'm the panelist here. I'm supposed to stay behind the curtain mostly. I will, let's just talk about a little bit about this really briefly. So ARIN's historical approach has been that you can have v4, you can have v6, it's your choice. We do encourage people, we try to do outreach, we try to tell people about it, but the moment you try to do more, ARIN, as the regional internet registry, we have a bit of authority, and we have to be very careful because nearly anything we do to more strongly encourage v6 gets in the way of keeping an accurate registry with v4. And so we need to use great caution. We don't want to tell someone, we're not going to work with you on getting more v4 addresses or updating your records or doing something with v4 because you're not playing with v6, because that first statement runs contrary to what Jeff said, job one, keep an accurate registry. Now, does that work for now? It does. Does it work forever? There may be a point in time when the people causing the network externalities for everyone need to be told, get with the program. I don't know. This is your ARIN and you're the community. It's actually you who tell me that vision.
So John.
Yes.
Why don't you just, anyone who comes for transfer space also say, by the way, here's your v6 on the side as well for free?
So we have had that happen actually. So there's RIRs who have experimented with when you come, you get a v6 registry even if you didn't ask. The problem is that sits idle, okay? The work that Lee spoke about with a deploy-a-thon of addressing plan and how you're going to use it, and unless that happens...
Yeah, but then when the technologist later finds out that the IP address specialist actually has the space...
You think it just happens?
Absolutely.
Okay, that's an interesting thought.
I had this happen where it's like, I don't know who to talk to go do this, but if you know it's there...
If you know it's there, maybe it'll be deployed. That's a good point.
Somebody can use it later.
If the community wants to do that, you get a V6, you have a V6 address, and you get a V6 address. Everyone gets a V6 address.
They're under your chairs.
All right, I'm going to go to the center rear microphone. Go ahead.
Kevin Bloomberg, The Wire. Two interesting words that came up through this whole thing. Building codes, compliance. Two words I heard.
Yeah.
Up to 5 years ago, 4 years ago, even today, V6 is an add-on, licensing-wise, for many vendors. You don't get into your car and say, I bought the seatbelt upgrade. I licensed the seatbelt on my car. Thankfully today, it's gotten a lot better with vendors and there is very close to feature parity. But I think what Gerald brought up is one of the key concerns. It's off. V6 is there. The feature parity is there when it comes to the standards, but it's off. That's one problem. So I think as an industry, we have to be much better about making sure that people don't treat V6 as an add-on. It is a building code requirement for the internet today. Don't call yourself an internet-capable device. Forget about this V6-ready stuff. Right. It should not be considered an internet-capable device if it is not feature parodied.
Got it.
My one question is, you mentioned 25 years, Gerald. You mentioned smart TVs. In the last 4 weeks, a number of IoT manufacturers, because of the market, have gone bankrupt. Tens of millions of devices are now dead in their homes. Thankfully, one of the downsides of IoT is it is not designed to last. So hopefully, the next iteration of IoT devices that people bring into their houses are V6 perfectly. There's no difference between them. They run V6, they run whatever they need to do. Right. We don't keep making the same mistakes. We've got the opportunity, whether it comes to equipment, refresh cycles, or whatever, to do V6. And just, I don't like the idea of 25 years because it is giving up on the fact that we do need to keep refreshing.
So just to respond a little bit, the reason why I said 25 years, and I brought up building code specifically, is I'm not sure when this hotel that we're in, right here was built. But at some point along the way, when you do a renovation to your network, when you go and you do these things, there's new standards that come along. And in my house, if I go and do a renovation, upgrade to my electrical system or something, some inspector is going to come in and say, hey, these things don't meet, they meet code when you were built, but they don't meet code now. And we need to be building that next infrastructure across the board. So, while John's saying, well, we're not going to allocate V6 to people unless they ask for it, unless the community decides by policy, I think if we as, I see ISPs in the room, I see others, if we're going and we're taking a forward-looking step on this and say, okay, I'm going to enable it on every port, I'm going to have it available, I'm going to have a shadow allocation for all of these customers, so when they come for it, it is there, I've built it to this new standard. Now, most network operators I know, they don't have the time to do this stuff other than solve the problems that are actually on fire. But when they get that time to do something, if the resources are available and they have the authority to go out and make those changes, they can go and build that in their next generation infrastructure.
So, Jared, the challenge, of course, is that building standards are things done by governments in order to make sure for the public good that a certain segment's operating in a certain manner. We don't have a lot of people who do public good standards for the internet that have regulatory authority. And yet, if you want to have someone say, I'm sorry, ISP, the gnat spew from your network is polluting the world, then you need a standard and you need someone actually to regulate. Are you asking for that?
So I'm going to turn this around to you, John, and say, John, you as ARIN accept credit cards.
Oh.
And when you accept credit cards, you have to record certain information, like
Right.
the IP address upon which I did the transaction from.
Yep.
And you have to go and do these compliance pieces that are associated
Right.
with that. So it may not be like, hi, I'm the internet police, I'm here to come and arrest you because you didn't do V6. But it may be that you have to undergo auditing and compliance work as your organization, as Akamai may or somebody else may, in doing this. And it may be indirect regulation and compliance that comes into play. That was the other thing Kevin mentioned. That, it's maybe indirect things like that where they're going to say, yeah, and you need to make sure that you're logging all of the V6 and the V4 addresses of these endpoints. And when you do a security scan.
It's possible that regulation in other areas for the benefits could cause the pressure you're talking about.
Absolutely. They cascade in just like supply chain things where you say, oh, I'm going to put in a vendor-supplier agreement, which is going to create that market.
Okay, do we have another remote? No? Yes? No? Okay, at the microphones, do we have someone? I recognize this guy. Go ahead.
John Sweeting with ARIN, but I'm really talking back to my ISP days. The point that the price is going to get too high for people to, people won't buy IPv4, I don't think that's really what's going to happen. As long as I have IPv4 space that's available, I'm not using. If I can't sell it for 1,000, I'm going to sell it for 500. If I can't get that, I'm going to sell it for 100. So I think as long as there's IPv4 space that's available, and we have to admit, as a community, we didn't do a great job with conservation because otherwise most of the IPv4 space would be used today. We wouldn't have so much out there available to transfer back and forth. So until the majority or all of this IPv4 space is in use, we'll probably still be seeing that transfer market.
It's a deep pool.
Yes.
Okay.
So I just wondered if there's any opinions from the panel on that.
Any panel views on that? That there'll be a market and good availability as long as there's a need?
Again, there's the diversity of kinds of buyers and sellers. So there is a lot of supply still unused, a lot of address space is still going unused on the internet, and that is a goal of ours, as a community. And we are still, Jeff gave the example of Reliance Jio in India, who decided to sell, they couldn't buy, and you gave the example of Mythic Beasts. I'm delivering web services on a Raspberry Pi. It's a $25 device, but addresses cost $50. My economics aren't working here. I'm not buying addresses anymore. Right. So that changes the marketplace a little bit. I think we see more and more of those cases where people stop buying addresses and look to alternatives as the price rises.
Demand.
There will be buyers. There are certainly organizations that can make $300, $1,000 per whatever they're selling that they need IP addresses for. They'll still buy as long as they need to do that. And I think that the market begins changing as prices change. Supply and demand. So maybe other sellers will say, well, I don't need the addresses. Quick, let me get out of the market. It will be interesting to see when the tide turns. If there's suddenly a flood, everybody going, oh, I missed the peak. Get out now.
Got it. I mean, it is interesting. I don't know if the ARIN community remembers, but we actually predate the market. The policy came first in 2009. The ARIN Board of Trustees said, Yeah, this isn't going to work without a market, because if you tell people your answer is return addresses and there's no other option, we're going to end up with no recording of transactions happening. So we actually established the market transfer policy prior to the transfers ever happening. And people say, why'd you do that? Well, okay, you can sort of see now the need for IP address blocks certainly is greater than I think a lot of us perceived. We thought it might be a brief thing when we ran out for a few years, and now we're talking about what's going to be the price in 10 and 20 years. But the market is now an essential part of this, and the question is it helping? Is it hurting? It's running on its own, and I guess I'm wondering, how does that affect V6? If the people on the panel have thoughts, I'll take that. Otherwise, I want to go to a question from the floor. Yes, Jeff.
This is Jeff, John, and I think you've got to remember that the internet was born out of 75 years of regulation, 75 years of acting as a public service utility under effectively a very tight relationship between the government, the sort of the public role, and the operator. When we took the brave step to actually unleash capital markets into this space, we were working on the principle that those incumbent monopolies were actually failing in their public duty. And we were relying, if you will, on a very rich competitive market to actually serve what customers need without knowing what they needed.
Right.
The idea is that markets themselves would react to customer need, focus on what the customer wanted, and deliver it at a competitive price. Now, I get my Netflix. This is working. All of a sudden, we're delivering over the internet stuff at astonishing price and astonishing capability. Now, I'm not going to stand in the way and tell $1 trillion industry how to spend its money, and neither can ARIN. You can't do that anymore. In some ways, the markets have actually taken on their own momentum. And the whole issue about this technology base is, again, a marketing-based issue. It's a market. And yes, there's a market for V4 addresses. Oddly enough, there's a market for V6 addresses. And the fact that ARIN gives it away at a relatively low price creates its own market dynamics. Now, what's going on here is entirely natural. What is unnatural is for ARIN to sit there and go, no, I'm not going to register a transfer. No, I'm not going to do this. And try and impose a constraint on a market. Because at that point, you're going to get into a tussle as to who has primacy here. And I suspect, being a bit of an amateur economist, that the money always wins.
Got it.
The money always wins. You know, whatever the market says, the market gets. So what we're finding right now is actually a transition to a very, very weird space. It's the rise of the server world, the content distribution networks. All the money is tipping into the application space and the content space.
Got it.
Why do we need globally unique addresses if most of my packets travel a few kilometres to the local data centre? And if you think about that question long enough, you really start to think about, what do we need in the next 20 years? A unique global addressing space, or enough to get my packets over the few kilometres to the local multi-petabit data storage, which is just in a curbside a few metres away from my house?
Got it.
And so in some ways, we love the old arguments. We love debating the 1980s and 1990s technology because we're all good at it. We've done it so often. But trying to look forward and trying to understand the market motivations that drive this industry is actually the hard bit. And I think the hard bit is trying to understand, at what point do we actually discard technologies which are becoming a boat anchor to the industry, which are actually becoming an overhead. And so in some ways, it would be good if we could ditch unique global addresses when we don't need them, when we've managed to sort of push this server world to a completely different space. And I suspect that this entire coping with the exhaustion of V4 has led to a feeling that we're never going to do this in V6. That running out of unique global addresses is not going to happen in V6 because we're not going to be reliant on unique global addresses anymore.
Got it.
We're going to build around this problem. So ponder that over your next...
Other than that, everything's fine. We've unleashed the market, and we have to realize with now the tail on the dog. We have time for one more question, I guess. Leif, go ahead.
Two more questions, I hope, because there's somebody.
Leif Sawyer, GCI
two.
Communications, Alaska. Do you think that V4 only is a technical debt issue? And if so, how do we get companies to address that technical debt turtles all the way down problem?
CIO Magazine, how are you dealing with your IPv4 technical debt? Panelists, who wants to go first? Vint, go ahead.
It's been, well, one possible way of dealing with that is effectively to say I won't buy the product unless it does V6. And this is one of the things, at least the U.S. federal government is now saying, at least on the Defense Department side, that the product that they buy must do V6, must be fully capable of running V6 only. So it's perhaps one way of imposing that requirement would drive people to at least implement it.
Got it. Yeah, very good. Anyone else want to comment on the V4 technical debt? I think we have one more question coming in remote. All right, let's go to our final question, remote question. Go ahead.
Dan Oakes, do you think the U.S. government requirements for IPv6 will have an impact at this time?
Question is, the U.S. government has adopted requirements for IPv6. Do you think it will have an impact on the deployment? Anyone want to pick that up?
No.
Since I brought it
No.
up,
Jared, no. But
I'll say that it will have a modest impact, but it probably will not have a global.
a moderate impact, but not on a global basis. Any other panelists want to comment?
I think the interesting, well, there's a lot of interesting questions embedded in that question, but one of them is, well, then what does the U.S. government do with their 170 million addresses?
What do they do with their own 175 million?
Right, the 175 million IPv4 addresses.
Okay, any final comments from the panelists?
Yeah, they'll pay down the national debt.
Their IPv4 debt, right.
It'd be amazing if the internet IPv4 pool bails out the U.S. government. I can't even go there. I'd like to take a moment to thank our panelists, both remote and local. Round of applause.
Thank you.
Thank you.
It was fun.
Thank you, everyone. It's been a wonderful panel. Thank you, remote panelists. And we're now going to go to break.